Okay, so now we're on question 7, and 7.1 says, determine f prime of x from first principles if f of x is equal to x squared plus x. So remember, this is 5 marks. This is really a place that you can score marks. In order to find the derivative of this function from first principles, what we can first do is find out what f of x plus h is going to be. So how we find f of x plus h? This is saying f of x plus h, meaning this x plus h is now being placed in place of x. Okay, it's been put here in place of x. So wherever you see an x, replace it with x plus h. So I see x squared, so I'm going to change that to x plus h. And because this is now replacing the x, you have to square that, so all squared. Then we have plus x, you're going to say x plus h, okay, because we're replacing it. And now we're just going to simplify this. So if we're foiling this one out, you can create 2 brackets, but that does take long. So you can deal with this the quicker method, which is really just to take this and you're going to say the x and we're going to square that, and that gives us x squared. Then we multiply the x and the h, which gives you xh. Then you times that by 2, which gives you positive 2xh. And then lastly, that h, you're going to square that, which will give you a positive h squared. Then plus x plus h. So that's the f of x plus h. So to find the derivative, you're going to use the formula that f prime of x is equal to the limit as h tends towards 0. And then you're going to say f of x plus h minus f of x all over h. Okay, so this is the derivative. It is from the gradient formula. So that's y2 minus y1 over x2 minus x1, which has been simplified to h. So this is equal to the limit as h tends towards 0. And then in place of f of x plus h, we're substituting what it is equal to. Then you have a minus, and then we have to minus this by f of x. So f of x is equal to x squared plus h. So we need to subtract this. But remember, this has more than one term, so you need to protect it with brackets so that that minus can have an effect on both terms. So x squared plus h all over h. And this is equal to the limit as h tends towards 0. We have to keep writing that until we substitute, and we're going to multiply that in. Okay, so everything here is going to stay exactly the same. And then when this one multiplies in, we just get negative x squared minus x. And all of this is over h. Now remember, you don't have to start searching for what's going to cancel. Whatever you are subtracting by is going to be what cancels. So I have a negative x squared, so there must be a positive x squared that cancels with that. And then I have a negative x, so there must be a positive x that cancels with that. And then I'm just going to rewrite what we have right now. That is 2xh plus h squared plus h all over h. Now, the whole point is to get h out of the denominator. So we're going to do this by taking out a common factor of h. So we're saying the limit as h tends towards 0. Take out h as a common factor, and we will be left with the first term, you'll be left with 2x. In the second term, you're going to be left with a positive h. And then you're left with a positive 1. It's really just asking yourself, what do I multiply to h to get back to 2xh? That will be 2x, and so on, all over h. And so like this, the h and the h would cancel. And now we have this. The limit, well, I'm not going to write the limit. I'm just going to substitute. So we only have this, and we can just go ahead and substitute. In place of h, we can substitute 0. So now I don't have to write that anymore. So this is 2x plus 0 plus 1, which of course, that means that f prime of x is really just equal to 2x plus 1. Okay, so another thing that you can also do from the beginning is take this and derive it from the rule of differentiation. If you do that, you already know what your answer is, and if it's wrong, you'll be able to check where you made a mistake. So if we use the rule, obviously, to derive this one, you'll say the coefficient times the exponent, which will give you 2, then x, then subtract 1 from that, which is 1. You don't have to write that. Then this x just becomes a positive 1, of course, because it has a 1 in front. And when you say the exponent of 1 minus 1, it gives you 0. Anything to the power of 0 gives you 1. And so 1 times 1 is just 1. Okay, so do that just to make sure that you have everything and it is correct. Okay, moving on to the next question. Okay, 7.2, we have to determine f prime of x if we have this expression as f of x. So this is for 3 marks. We have to use the rule of differentiation. So f prime of x, this is already ready to be differentiated. There is no x on the denominator. We don't have any x in a surd. So this is fine. So we're going to first of all take the coefficient of this and we're going to multiply that by the exponent, and that will give us 10. Now we have x. Then you have to subtract 1 from that exponent, and that gives you 4. Same thing over here. We're taking the negative 3, that coefficient, times the 4, which gives us a negative 12. Then we leave the x, and we subtract 1 from that, and that gives us 3. And then with the 8, we have a positive 8 as the coefficient and an invisible exponent of 1. So 8 times 1 is positive 8. We have x. And then we have to say 1 minus 1, which is 0. And anything to the power of 0 becomes 1. And 8 times 1 just stays 8. So that just stays like that. Okay, so this is what we have. And that is f prime. And it's for 3 marks. So this is a really good 3 marks that you can get. It's a very simple one to derive. Okay, question 7.3 says, the tangent to g of x is equal to ax cubed plus 3x squared plus bx plus c has a minimum gradient at the point -1 and -7. For which values of x will g be concave up? Okay, so we're trying to find out the concavity of this function. Okay, so let's look at the information they've given us. Well, they told us that the tangent to a function has a minimum gradient at this point. And in this function that they give us, a, b, and c is missing. That's a lot of things that are missing. Okay, there's a way that you can solve this by actually just using what you know about cubic functions. So they're saying the tangent to this function has a minimum gradient. Let's think about that carefully. You have a cubic function, but the thing right now is we don't really know what this cubic function looks like. We don't know if a is greater than 0, and so therefore it looks like this, which is really the shape of a capital letter N, but just more curved. And we also don't really know if a is less than 0, so if it looks like a backwards N, just more curved. We're not really sure what it looks like yet. Okay, now that we have these two, because they speak about the gradient, they say it has a minimum gradient. Just remember, if you have this type of parabola, something that looks like this where a is greater than 0, if you derive this cubic function, you're going to end up with a parabola that is concave up because the a value was greater than 0. And this one, you end up with a parabola that is concave down. Okay, now the thing about this is that they tell us that the tangent, so there's also a tangent that we have to take into account. The tangent to this has a minimum gradient. So when you're finding the gradient of a cubic function, those are the parabola, because when you derive the cubic function, you get a parabola. So this represents the gradient, but they're saying that it has a minimum gradient, meaning its gradient, okay, has a minimum value. So the only type of gradient of a cubic function, in other words, the only type of parabola of a cubic function that will have a minimum value would be this one, because this has a minimum value. Here's your minimum. That's the lowest point that this parabola can go. This one has a maximum. So now immediately we know what the graph is going to look like. So we know for sure that a is definitely greater than 0. Okay, so that's our a value over there. We know that a is positive. Okay, let's try to see what we can do with this now. Now we know the shape of the cubic function. So let me put down a Cartesian plane and actually draw this down. So the cubic function I know now looks like this. Now, taking into account the information we have, we also know the gradient, okay, of this cubic function creates a concave up parabola. So I'm also going to draw that in. So concave up parabola. But I'm going to try and keep that turning point at this point this side of the x-axis, because they do tell us that this tangent to this has a minimum gradient at this point. Okay, we'll still draw the tangent in and then put down that point, but I know that it has a minimum gradient at this point, so its x value is -1. So if it's here, something like that, then we know, okay, this is our minimum. So what they're saying is that this cubic function, let me actually correct the way it looks quickly. Okay, so the cubic function, which is of course g, this cubic function has a tangent being drawn to it at this point. Okay, that tangent has a minimum gradient. So here at this point, so we know that since the tangent has a minimum gradient, where we have this minimum value of this parabola, which represents the gradient, that's that minimum gradient. Okay, this tangent is going to be perfectly in line with this point so that their gradients are the same. Okay, because when you move along the graph, the gradient changes. So that it has a minimum gradient, it's perfectly in line, vertically in line. So that point could be over here. And so that tangent could look like this. I have to draw it like this. I can't really draw it like this because then it wouldn't be a tangent. It would cut here and here. So that's not a tangent. A tangent must cut a curve only once. So I have to draw it like this. That means this is what the tangent probably looks like, something like this. And this tangent is cutting only once. Just pretend it's cutting once. I'm actually supposed to rotate it a little bit. It would look like that, something like this. Okay, so this is what we have. Now, the points that it's cutting the cubic function itself is at -1 and -7. So that is at -1 and -7. And this is already saying a lot. Because we know now that this has a minimum, okay, gradient. This is really what this means. You need to remember how cubic functions and their derivatives work. When you have a cubic function that looks like this, if you derive it, it will become a positive or concave up parabola. Okay, something you should remember is that the point of inflection of this cubic function, you see that x value, it's going to be the exact same x value as the turning point or that minimum value of your parabola. That's going to be in line with each other. So that, since we have a minimum gradient here, and this is perfectly in line with this point, which is -1 and -7, that means that that point is your point of inflection. So we know the point of inflection now. So I'm going to just say that the point of inflection is -1 and -7. And just like this, we'll be able to solve this question. We need to find out for which values of x it's going to be concave up. Okay, for a graph to be concave up, when you have a function, we already know what it looks like. You have to just find the point of inflection. If you find the point of inflection, all it just means is that wherever it looks curved up, this part over here, that is where the graph is concave up. And then this part over here is where the graph is concave down. So since we know that this one is concave down here, this one is concave up here, we're just looking for the part that is concave up. We already know the x value that belongs to the point of inflection. It's -1. So it's concave up for all these values over here. Everything here, it's curved upwards. See, so that's concave up. So these are, we have to see the x values that belong to these points. Looking at it compared to -1, these are all values that are greater than -1. All of these, they have values greater than -1. So the values of x for which this graph is going to be concave up is where x is greater than -1. Okay, so that's one way of solving that question. But that's actually how I would have done it. I am more of a visual learner, so I would rather do this and just draw out the graphs to try and make sense of it. Okay, so that is it for question 7, and then we move on to question 8. Okay, so question 8, we have this. Okay, so the graph of y is equal to f prime of x is equal to mx squared plus nx plus k is drawn below. Then they tell us that the graph passes the points P, which is -1 over 3 and 0, Q 1 and 0, and R 0 and 1. And first of all, we have to determine the values of M, N, and K. So we have to basically find the equation of this parabola. Okay, just pay close attention to what they have given you in the parabola. First of all, they gave you an x-intercept, gave you another x-intercept, and then they give you another point. Whenever they give you two x-intercepts, you can use the x-intercept formula of a parabola, which looks like this. It says y is equal to a bracket x minus x1 multiplied by x minus x2. So these would be your two x-intercepts, those x values. So we can actually use this, okay? But because they strictly did say that we would have to find m, n, and k, I can actually just call a m, okay? Because here it's in the form of ax squared plus bx plus c. So as you can see, because a is in line with m, then that is m. So I'm just going to change that to m. Okay, so now x1 and x2, this is what we have. x1 is the first x-intercept, the x value of it, which is negative 1 over 3. And x2 is 1, and the second x-intercept that we have. So we can just substitute these first into the equation. So we have y is equal to, then we still have the m, open bracket, x minus x1, so that's going to be minus negative 1 over 3. But remember, minus negative 1 over 3 is just going to be plus 1 over 3. So I'm going to change that to plus 1 over 3. Then we have x minus 1. Okay, so that's the x-intercepts in. And now that we have this, as you can see, it's almost complete. The equation is almost complete where you just have y and x's. The only thing that's missing is m. So to find m, you can just take this other points that they gave you and substitute it in. So we can go ahead and just substitute r, which was that 0 and 1. So you're going to substitute this in place of x and y. Okay, so let's go ahead and do that. So we have y, so I'm going to put that as 1. So 1 is equal to, and we have m multiplied by x, and x is 0, so we just have 0 plus 1 over 3, and x again, which is 0 minus 1. Okay, so simplify. Let's just figure out what these ones are going to be. So first of all, 0 plus 1 over 3 is just 1 over 3. 0 minus 1 is negative 1. So that's 1 over 3 times negative 1. What does that give us on the calculator? So 1 over 3 times negative 1, that's of course going to be negative 1 over 3. Okay, so we have m and then negative 1 over 3 and 1. So we just need to solve for m by getting rid of this negative 1 over 3. If you divide both sides by negative 1 over 3, so here we're going to have that m is equal to 1 divided by negative 1 over 3. You can put that on the calculator, but it's just going to become negative 3. So there, we found m. Okay, we found the value of m. Now to find n and k, you can just substitute m back into the equation and simplify, put the equation in standard form, and naturally you'll be able to see the value of n and k. But honestly, k is easy. K is y-intercept, so that's k. But either ways, we can just go ahead and put it in standard form just so that we can find n at least. So this is y is equal to the equation of it, and I can call it y is equal to because they did say y is equal to f prime of x. So y equals, and we have negative 3 multiplied by x plus 1 over 3 multiplied by x minus 1. And now if we go ahead and simplify this, equal to negative 3, and let's just FOIL this out. So that's going to be x squared negative x positive 1 over 3x and negative 1 over 3. Now simplify negative 3, we have x squared. What is negative x plus 1 over 3? That's like saying 1 over 3 minus 1, because that's the coefficient that we have there. Now this is a positive 1 over 3. I'll just change that to a 3 over 3, which is going to be negative 2 over 3. So you can use a calculator as well. Negative 2 over 3x and then minus 1 over 3. Then I'm going to just multiply this in. So y is equal to negative 3x squared positive. So you see the 3, I know that it's negative and negative. So it becomes positive. But the 3 is going to cancel with that 3 on the denominator because this is naturally on the numerator. So we have positive 2x remaining. Then, likewise with this, the negative and negative give you a positive, but the 3 ends up cancelling with the 3 on the denominator, which gives you positive 1. That's what's left on the numerator. And that's what we have. So this would mean that now that it's in this format, this would mean that m, and this is n, and this is k. So it means that m is equal to negative 3, n is equal to 2, and k is equal to 1, which we could already see from here that k was 1. Okay, so that's how to solve for this. You have to use the x-intercept formula of a parabola. Okay, moving on to the next question. Okay, 8.2 says if it's further given that f of x is equal to negative x cubed plus x squared plus x and then plus 2, we have to determine the coordinate of the turning points of f. So to find the stationary point of a cubic function, what you're going to do is we use this logic. To find the stationary point, at the stationary points, your gradients are standing still. They're not moving. They're neither increasing nor decreasing. And so because of that, the gradients are specifically just equal to 0. So what we're going to do is find the gradient of this function and set it equal to 0. To find the gradient of this function, you just derive it. So we're going to make f prime of x equal to 0. Okay, let's derive the function. So that is negative 1 times 3, which is negative 3. Then we have x, then minus 1, which is 2. Then that is going to give you a positive 2x. Okay, 2 times 1. Then subtract 1 from that, which is 1. You don't have to write that again. Then we have plus 1, of course, because we have the coefficient times the exponent, which gives you 1. The x, then we have the minus 1 from the exponent, which gives you 0, which anything to the power of 0 is 1, and 1 times 1 stays 1. Then the constant falls away, okay? It really just becomes 0 because you're finding the gradient of each of it. Gradient of a constant is 0. Okay, so this is what we have. We set this equal to 0, and then we just have to solve for x now. So since this is negative, it shouldn't be negative if you want to nicely factorize. I'm going to get rid of that by dividing both hand sides by negative 1. And so we have 3x squared minus 2x minus 1 is equal to 0. Then you would have to factorize this. Now, there is a hack. You can use this hack. Just don't show them that you use the parabola, the quadratic formula. So how you can factorize or pretend to factorize it is by doing this. So on your calculator, you're going to substitute this in as if you're using the quadratic formula. So we can just go ahead and say negative b, so that's negative, and b is negative 2. So negative 2, bracket negative 2, plus minus, I'll start with the plus, square root of b squared, but b is negative 2, so negative 2 all squared, minus 4, and then a is 3, and then c is negative 1, over 2a, and a is 3. Okay, so you see the first solution we get is 1. This is how we're going to look at it. I'm going to open up two brackets as if I am factorizing. And I know that this is equal to 1. So that is the factor that is less complicated. It's a whole number, or an integer rather. So I'll say x is equal to 1. This is the solution for it. But when I am solving here, I'm just going to say, to get the factor, it's like taking 1 over, which is going to give you x minus 1. So the factor is x minus 1, therefore the solution is x is equal to 1. Okay, to find the other factor, I would change the sign now to a negative, so minus now. And then this is what I get, but it should be a fraction. So there, it's negative 1 over 3. And this is how I'm going to put it. I say x is equal to negative 1 over 3. And now I use the same logic here. I'm kind of taking this over, and this is now x plus 1 over 3. But then it's not supposed to just look like that. The thing about this is that whatever is here is actually supposed to be your coefficient of x. So you take this to the coefficient of x, so that's 3x plus 1. That's actually what your factors would have been, 3x plus 1. So you can get rid of that, just write that in pencil. And so there, it looks as if you factorized and you got your solutions. The only reason I do this is just in case they actually do require you to give them factors and they'll give you a mark for the factors. I don't think they do that as much anymore though. Okay, but now that we have these as our factors, all we're going to do is, these are the x values, okay, of the stationary points. To find the y values, you would just take these x values and substitute it into the equation. So I'm saying f of -1/3, I'm substituting this x value in, is equal to, we have negative x, so negative bracket -1/3, all cubed, then plus -1/3 or squared, then we have plus x, but I don't have to say plus -1/3 because this is going to multiply and become negative. I can just say -1/3 and then plus 2. So you can go ahead and substitute this into your calculator and see what you get. Okay, so the first solution we get is 49/27. So that is for -1/3. So let's also find the one for 1. So 1 is equal to negative bracket 1 cubed plus 1 squared minus, not minus, plus. Okay, that was a plus x, plus 1, and then plus 2. Okay, so f of 1 is equal to, we substitute 1 into the equation, and then we get 3. So there, our stationary points, or our turning points, is specifically called the turning points. So the turning points are -1/3 and 49/27 and 1 and 3. So those are our coordinates of our turning points, and that is 3 marks. So it's a very simple thing to do for 3 marks. Moving on to the next question. Then 8.2 says, draw the graph of f, indicate on your graph the coordinates of the turning points and the intercepts with the axes. So good thing about this is we already have the turning points, and the intercepts with the axes, we can actually find them because of this. So remember how a cubic function, right, when you derive it, it becomes a parabola. Well, this is the derivative of that function that we have. Okay, it's still the same question. So the derivative of this function, since this cubic function is concave down, the type of cubic function that you're going to have is going to be a function where a is less than 0. And this is going to look like a backwards n, just more curved. So we already know what this is going to look like. It's going to look like a curved n, something like this. Okay, now I'm just doing this only so that I can find the things that we need to look for specifically. Okay, so the x-intercept of the parabola is going to be the same x value as the turning points. Those ones, they're not really a problem because we already found the turning points. The things that would need to draw this cubic function is we need to know the y-intercept of the cubic function. We also need to know its x-intercepts. Now, right now, that's what we don't have. So clearly, we have to find those. And now it makes sense why they would give us 5 marks for this. It's clearly because we still need to find those x-intercepts, which we do not know. We do, however, know the equation of the cubic function. So this is this, right? So we have f of x is equal to the negative x cubed plus x squared, and then that was plus x plus 2. Okay, so plus x plus 2. So we have this, and what we're going to do now is we're going to have to factorize this in order to find the x-intercept. Okay, so before finding those x-intercepts, let's just state everything we have. We have the turning points of this, okay? And let's just put them down so that we know that everything is here. We also know the y-intercept. You see, the y-intercept, this is already in standard form. The y-intercept is always going to be that constant, that value without a variable in it. So it's 2. So as a y-intercept, naturally its x value is equal to 0, meaning your y-intercept is just 0 and 2. So we have all of that. The only thing we need to find now is the x-intercept. To find the x-intercept of a function, you need to just make y equal to 0. So we're going to say 0 is equal to negative x cubed plus x squared plus x plus 2. And now we have to factorize this. So this is a step where we have to actually factorize a cubic function. So since we have to factorize this, we have to use one method of factorizing cubic functions to factorize this. I'm personally going to use the synthetic division method because I like that method more. So with the synthetic division method, first of all, you're going to look at the constant and you're going to find factors of that constant. So factors of 2. Now factors of 2, you're going to have to take positive and negative factors as well. The first factor of 2 will be 1, and so the second one will be negative 1, and then 2 and negative 2. And what we're going to do is we're going to substitute these values into the function, and we need to find the one that actually gives us 0. See, we're saying 0 is equal to that. So we need to find the one that actually gives us 0 because that one will be a root or one of the x-intercepts. Okay, so I first of all tried 1, and as you can see, it's not working. It didn't give me 3. Also notice I put brackets just so that it's easier to substitute in case like I'm substituting a negative number. Okay, so I'm going to try negative 1 next. So if I make that negative, let's see what we get. So that gives us 3. That is not 0. Let me try 2 next. Okay, so when I try 2, it works out. It gives us 0. So it means that 2 is a root. Okay, so since 2 worked, then it means that x minus 2 is a factor. Okay, that is a factor because x is equal to 2 is one of your solutions. So it's just like taking that over. So x minus 2 is a factor of this, okay, cubic function. So there may be an easier way of doing this, but I'm just going to try and do this whole synthetic division just for anybody who wanted to maybe learn it. Okay, so here, now that we found out that 2 works, what we're going to do is we're going to draw an L, a letter L, but backwards. So like this, that has a really long tail. Then we're going to put the number that worked here, so 2. And then in here, let me actually just make this straighter. So in here, what we're going to put is the coefficient of all your variables. First of all, the coefficient of x cubed is negative 1. So we're going to put that here, negative 1. Coefficient of x squared is positive 1. So we have a positive 1. And then we have another positive 1. And lastly, the constant, which is a positive 2. And this is how synthetic division works. Step 1, you drag this number down. That negative 1, we just drag it down. Then you say negative 1 multiplied by the 2 here. And that gives you negative 2. And you put that on top of here. Then you say negative 2 plus 1, and that's going to give you negative 1. Then negative 1 multiplied by 2, which gives you again negative 2. Then negative 2 plus 1, which gives you negative 1. Then lastly, negative 1 times 2, which is giving you negative 2 again. And then negative 2 plus 2, which gives you 0. Now this is the thing, you should always end with 0. If you end with 0, then you know that you had multiplied and added properly. So this is our factors. You see these numbers here, they represent the coefficients of your parabola that you're going to have. When you factorize this, it's going to be a quadratic expression. So this is the coefficient of x squared, this is the coefficient of x, and that's your constant. That's how this is going to work. So it means that in our expression, what we had is this, 0 is equal to all of this, right? But now we're going to have 0 is equal to, and the first factor that we already had was this x minus 2. That was a factor. So we have x minus 2. And then in this bracket, we're going to put our other factor, which is these ones with their coefficients, of course. So the coefficient of the x squared is negative 1. So we have negative x squared. And then we have negative x. And then a constant of negative 1. So that would be this factorized. Okay, so now we have to just try and solve for x. So the first one is quite easy. X is just going to be equal to 2 because you're taking negative 2 over. Then we have or, and then this one. Now this one already looks really weird. Definitely cannot. So because even if you decided, okay, let's make the coefficient positive. So we divide both sides by negative 1. Then you're going to get x squared plus x plus 1 is equal to 0. Already looking at this cannot be factorized because if we have x multiplied by x, and now we have to find out what multiplied by what would give us a positive 1. Well, that's 1 times 1. But when you add these two, they should give you the coefficients of the middle. And we can clearly see that's not happening. Now, another way to find out whether this does not have solutions is to actually just use the quadratic formula on it. Then you see that it will not factorize. As you can see on the calculator, it is ending with I, so that is not a real number, so it doesn't have solutions. So here x has no solution. You can just say x has no solution, and that's okay. So it means that it only has one x-intercept, which is 2. So the x-intercept that we have is 2 and 0. That's the only x-intercept that we have. Okay, let's try and plot this graph now. So you're just going to plot all the points that you do have, and let's see how it works out. Okay, so this is all our points. We have a turning point, we have a y-intercept, and one x-intercept. So just draw down a Cartesian plane. And now I'm going to put down the values because I don't want to start writing numbers. We don't have to do that. So we're going to plot down the values. First of all, on the y-axis, the only value I see that we have is the 2, this one, okay, for the y-intercept. So I'm going to plot that down. I have a 2 over there. You can plot it as 0 and 2, but even if you said 2, that just makes sense. It's fine. It's a y-intercept anyways. It's not a normal point. And then we have an x-intercept of 2 itself. So that's over here, and I'm just going to put that as 2. Okay, then we have turning points. So the turning points we have this and this. 1 and 3 is going to be somewhere here. 1 and 3. So that's 1 and 3. And then we have this negative 1 over 3. So negative 1 over 3 is just a third. And 49 over 27, I'm just putting it down because I just want to see roundabout where it is. 49 over 27 is like almost at 2, almost at positive 2. So negative 1 over 3 and almost at positive 2, we have that. The points, you just have to make sure that you are writing those coordinates down. That's negative 1 over 3 and 49 over 27. Okay, now we can draw down our cubic function. Remember the shape of it, because we had that f of x was equal to this. The a value is negative, so your graph is going to look like a backwards n, just more curved. Okay, so we're going to have to try and draw it like that, noting where the turning points are. In other words, noting where we need to curve. So we need to curve here and here. So it means that our cubic function is going to look like this. It's going to come down like this. And then it's going to go up like this, cross that y-intercept. And it's going to stop here and curve and then move downwards and pass that x-intercept. So it's going to look something like this. Not the most perfect graph, but that's roughly what it would look like. And then just name it f because it was f of x. So there we go. And they will give you 5 marks for all of that, for basically finding that x value of your x-intercept and sketching the graph down. Okay, so that is our cubic function. Moving on to the next question. Okay, so 8.3, we have points E and W are 2 variable points on f prime. So they're probably speaking about still f prime. It's still this question basically. So on this graph that we have over here, the one that they gave us in the beginning, this graph, I don't need that anymore. Okay, so we have 2 points on this graph. For the sake of understanding, I'm going to copy this graph and then put it there. Okay, and then they say that, so these points E and W are 2 variable points on f prime and are on the same horizontal line. Okay, so there is some sort of horizontal line. Let's just say it's here. And we have these 2 points on the same horizontal line. Okay. And of course, they are on F. They did tell us that they're points on F and they're on the horizontal line. So this is E and this is W. So E and W. Then they tell us that H is a tangent to F prime at E. Well, tangents are straight lines. So we have a straight line that is a tangent to this graph of F at the point E. So since it's at the point E, supposing that E is over here, then this tangent must look like this. Because it's a tangent, it must only cut the graph once. So it's going to look something like this. And it basically just touches the graph once. Okay, so that is our point. That's our H. So I'll label that H. Okay. Then they also tell us now that G is a tangent to F at W. So G is a tangent to F at W. So we have another tangent here. By default, we have to draw it like this. So we have to draw it like this. something like that. Okay, let me just correct what it looks like. Okay, so that's what that looks like, and that graph is called G. Okay, then they tell us that H and G intersect at D. And this is the coordinates we have, A and B. So these two graphs eventually intersect. So looking at the way it looks, it's clearly going to intersect as they go up like that, then they intersect. So let me just extend them and then show that point of intersection. Okay, so there they intersect at this point. And we're calling that point D, which is A and B. And the question is, we just have to find the value of A, that's all. So that value. Okay, so this doesn't seem that bad given that we already know what the equation of f prime of x is. Okay, so remember that f prime of x is equal to, honestly I forgot what it was equal to. Let me just see what it is equal to again. Okay, it was equal to this because we found the equation of it. Okay, so let's also look at the other information that they gave us. Well, they told us that these are two variable points. So variables are like letters. We don't really know what the numbers of these points are, but we do know that they lie on the same horizontal line, meaning their y value is going to be exactly the same. So if this was like a half, then this y value is also going to have a half, and that y value will also be a half. Okay, but as for the x values, we don't know what that is. So the x values are different. Because of that, I can call this one P, and then the y value, let's just call that Y. And then with the other point as well, I don't know what its x value is. I'll just call that Q. And the other point, I'm also going to call Y, just to really emphasize that the Y values are going to be exactly the same. Okay, so it's interesting that they don't ask for B. They only ask for A. Okay, so the fact that it lies on a horizontal line, this is actually where we'll be able to solve for this. Okay, let us use the x-axis quickly. You see the x-axis, something that we understand about the x-axis is it is a horizontal line. And the points of intersection of this graph and the x-axis are your x-intercepts. Now, before looking at those x-intercepts, let's just look at something quickly here, right? With this line, because this is a flat horizontal line and it's being drawn from a point with the same y value, okay, as this point. It means that this right here would be an isosceles triangle that we have. From this point to this point of intersection will be the exact same distance as from this point to that point of intersection as well. Because this is a straight line, it is constant, it's consistent, it's not going to change its shape. It's going to keep constantly going in the same direction with the same gradient. So because they are from the same horizontal line, they're going to meet, okay, exactly at the middle of this parabola. So looking at the x-intercepts, if we were trying to find that exact middle point, okay, because this will be the middle point since these two are exactly the same lengths. If we're trying to find the middle point, that will be the midpoint of these 2 points over here. If you find the midpoint of the x-intercepts, you would find exactly what the middle point is. And so that would be the x value you will have and the y value as well. And that x value would belong to the x coordinates of A. They are intersecting at the midpoint of this line, which is also the midpoint of the x-intercepts because of the way a parabola behaves. A parabola is going to always be symmetrical about its turning point. So there's two ways to find this. You can either find the x value of the turning point of this because that will be the midpoint, or you could physically take these 2 points and find the midpoint of it. That midpoint, that x value is going to be the same x value that we have, okay, in between here, and also the same x value where these two graphs intersect. Okay, so I feel like any method you use would still work. You can use the finding the x value of the turning point, which you would just say x is equal to negative b over 2a, and then you find it. Or we could also just use the midpoint formula and say x is equal to x1 plus x2 over 2. And of course, y1 plus y2 over 2. But we don't really have to find the y1 and the y2 because they're both just 0. It's going to stay 0. So we can just focus on the x. So that would be negative 3, 1 over 3, sorry, plus 1 and divided by 2. Okay, so let's see what this gives us. Okay, so as a fraction, that gives us 1 over 3. So it means that x is equal to 1 over 3. And that is the x value of this point, which is a. So it therefore means that a is just equal to 1 over 3. Okay, just remember you can also use this. It will also give you the x value of the turning point, which would be the midpoint of the two x-intercepts and even these 2 points, as long as they have the same y value. When you're trying to find the midpoint of it, okay, it's going to be exactly the same. If I put down a horizontal line like this and I try to find the midpoint of these 2 points, it's still going to be in between here again. Because of the way the parabola behaves, it is symmetrical on the left and the right hand side. Okay, moving on to the next question. And then 8.3.2, we have determined the value or values of b for which h and g will no longer be tangents to f prime. Okay, so looking at this graph, how can we make these two lines to no longer be tangents to this graph? So by definition, a tangent is a line that cuts a graph only once. And that's what these two graphs are doing right now. They're cutting the graph here and here. But we want these two graphs to no longer be a tangent, but they want us to determine the values of b for which this will happen. So we're going to control these two graphs, using the b value, meaning we are still keeping in mind that they are going to still be intersecting. But we're going to have to see what b should be in order for us to do this. Now, honestly speaking, in my head, I can see the way this looks, but I know you may not be able to see it in your head as well, and I can't just say it with words. So I'm going to create an animation for this and then explain this using that animation. Okay, so we're looking at these two tangents, h and g, and we have to manipulate them from the point of D. Okay, so we're manipulating that value of B so that these two tangents are not going to be tangents to this graph of f prime anymore. Okay, so first of all, since we're trying to manipulate the value of B, B is the y value of this coordinate of D. If you're trying to manipulate a y value, if you change its value, you're either going to move that point up or down because it's a y value. So it's either going to move up or down. X values move left and right, but we're trying to manipulate b, and that is the y value. Okay, so now that we understand that we need to either move that point up or down, okay, and not saying the graph, the points, because they said specifically b, and that is a coordinate, okay, that's the y coordinate of that point of D. Okay, so let's think about that. If we move that point up, so that means we're just taking the value of b and we are increasing it to higher than whatever it was currently. So if we do that, look at what happens. So if b is at a higher place now, then look at what's going to happen to the graphs. You see, these tangents, look at what happens to them. D is still the common point of intersection. We know this because they told us to manipulate B, which is the y value of D, so that these two are not tangents anymore. So we are moving it from this point. And you see what it did to the graphs? Well, doing that doesn't really solve the problem because they're still tangents. And because they're still tangents to this graph, it's not going to work. We need them to not be tangents anymore. Okay, let's try moving it higher than when it currently is right now. So if we move it higher, look at what happens to the graph. See, it still doesn't solve the problem because h and g are still tangents to the graph of f. Now, because of the way the parabola works, and because of the way it is curved, it's still not going to solve the problem. If you keep moving that point up, if you keep manipulating b to be a higher value than what it was. So, how about we try moving this parabola down? But let's just reset it and put it back to what it originally looked like. So this is what it looked like. Now we're going to take that point, or we're really manipulating the value of b, and we're going to manipulate the value of b to make it a lower value than what it currently is right now. Let's look at what happens to the tangents. You see, now the tangents, they are still tangents to this graph. They're still intersecting the parabola at one point. So that doesn't solve the problem. but we're getting somewhere. Let's move it even lower. So when we move it even lower, you see that it's getting closer to the turning points. We're just trying to make these tangents not tangents, meaning they must not touch that parabola once. Okay, so let's see. How about we take that point and we move it right to the turning point, okay? Let's move it right to the turning point of the parabola. And look at what happens when we do that. Let's just monitor the graph of h first. Let's see what happens. If you move that point of D and you make the B value to be exactly the Y value of your turning point of that parabola, look at what's going to happen to that tangent of h. See, it's still a tangent to this graph, but now it is a flat horizontal line, which makes sense because at the turning point, the gradient of the turning point is 0. So it makes sense that it's making a flat horizontal line because horizontal lines have a gradient of 0. That's why they're flat. That is the ground we walk on every day, unless you live on the mountains. Okay, and the graph of G does the exact same thing. The gradient is 0. This is a flat ground. Okay, so moving the graph down, it's still a tangent when we move it down until the turning points. The thing about this is, yes, they look different now. They're both in the same position, the exact same place, to a point that they're just literally overlapping each other. But there's still a tangent to the graph of f. They're tangents at the turning point now. So let's take that point D, right? We're manipulating the value of B. Let's make B a lower value than what that Y value of the turning point is. Let's see what happens when we do that. Okay, so if we move that down, let's see what's going to happen. And let's just monitor first of all the graph of G. Okay, so remember they are going to move at the same time, but I'm just moving it one by one so that you can see what's happening. If we move the graph of G, do you see now, is this a tangent now to this graph? No, it's not a tangent anymore. And because it's not a tangent because it's intersecting the parabola at two places, not one place anymore. So it's not a tangent anymore, it's now a secant. Okay, let's take the graph of H and let's do the same thing because they're actually supposed to move at the same time. So there we go. The graph of H is also now a secant. It's intersecting the parabola at two places. So if we take the value of B and we make it lower than whatever the Y value of the turning point is, then it's not going to be a tangent anymore. They're going to be secants. So we're taking it from that point over there. And we have to find out what exactly that point is. If we can find out what that point is, then we'll be able to find out what exactly we need to make the value of B to become less than. Okay, because B must just be less than whatever that value is. Then it's going to be a secant and not a tangent. Okay, so looking at that value of B, what can we do? Well, first of all, since we're trying to find out what exactly that's going to be, we can take the actual formula for the parabola and we can substitute 1 over 3 since it is the x value of the turning point. And to find the y value of the turning point, we can substitute that into the equation. And when we do that, we get 4 over 3. So now we know what's there. That's 4 over 3. That is the y value of the turning point. So if we can just make that b value to be anything lower than 4 over 3, then it's going to make these tangents not to be tangents anymore, but rather to be secants. So b just needs to be less than 4 over 3. Okay, and that's how we solve that problem. Okay, so from the animation, you would have seen that all you really needed to do was find that y value of the turning point and finally tell them that b needs to be less than 4 over 3. Okay, and that's it for question 8, and then we move on to question 9. Okay, so question 9, the last calculus question for this paper, we have given f of x is equal to x squared, we have to determine the minimum distance between the point 10 and 2 and a point on f. Okay, they at least told us what f of x looks like. It is x squared, which is just the mother graph of a parabola. So it basically looks like this. So this is our mother graph of the parabola. That is our graph of f. And we have to determine the minimum distance, okay, between the graph of f and this point, between this and this point. So 10 and 2 is like 10 and 2. So 10 and 2 is over there. And we just have to find the minimum distance. Okay, so the reason they say minimum distance is because there's different ways to find the distance of this point and this graph. You could have been looking at it like from a point over here till there. But that's definitely not the smallest distance. That's not the minimum distance. You could have also been looking at it from like here to here, or even here to here. Okay, so we just want to find out the minimum distance. It can be from numerous points, but the lowest one basically. Because you see the word minimum, it's going to have to do with deriving at some points, and then we're going to have to find the minimum value. So let's go ahead and just try to find the distance of this parabola. In order to find the distance of 2 points, naturally you need an x and a y value of both points. Here we have an x and a y value. We have 10 and 2. But the other point, remember, the other place that we are looking for, the other points that we're starting from, is this parabola f of x is equal to x squared. We don't have an x and a y value. So what we can call it is, we're just going to say, let me just get rid of these other lines and just going to say, let's say this is the minimum point. Okay, the x value belonging to this graph, because we don't have an actual number, we will call that x. And so the y value would just be the result of substituting x, which would be x squared, okay? F of x is equal to x squared. So the y value is x squared. So we're trying to find the minimum distance of this line using these 2 points as our 2 points on sort of like a line, okay? So that would make this your x1, and that can be x2, and that can be y1 and y2. What did I just write? Sorry, I meant x1 and x2 and y1 and y2. There we go. So those 2 points, we're just going to try and find the distance of that. Okay, so let's use the distance formula. The distance, I'll just call it d for now, is equal to the square root of x2, so x2 minus x1 all squared, plus y2 minus y1 all squared. So that's how we find that distance. Then we're going to say the distance is equal to, and substitute. So the square root of, and we have x2, which we said is 10. So that's 10 minus x all squared. Honestly, I want the x to be first. I'm going to change that to x1 and that one x2. Okay, so that means this is now x2, which is x minus 10 all squared, plus y2, which is the x squared minus 2 all squared. Okay, so now that we have this down, what we're just trying to find is the minimum distance. So if you want to find the minimum distance, the lowest distance, we can just simplify this as far as possible. And then with that expression, if we can find out where that expression will be a minimum value, we can take that expression and substitute it back into this distance formula. Okay, so let's just simplify this. So we're going to have the square root of, and we have, first of all, this is being squared. So I'm going to take the x and square it. That's x squared. Then x multiplied by negative 10 is negative 10x. Then multiply that by 2, which is negative 20x. And then negative 10 all squared. 10 squared is 100. So that's positive 100. Then here we're going to have the same situation as well, because we have 2 terms and we're squaring it. So we take x squared and we square it, which will give us positive x to the power of 4. And then we're going to take the x squared and multiply it by the negative 2, which is negative 2x squared. Then you take that and multiply it by 2, which is negative 4x squared. Then the last term is a negative 2. You square that and that gives you a positive 4. Okay, so that's just a quick way of simplifying instead of taking 2 brackets and then distributing it. Okay, so we're going to have the square root of, and let's just put our like terms together. So we have x squared and we have a negative 4x squared. Those can go together. But I'm going to put them in the order of the exponents. So highest exponents to lowest. So the highest exponent is that x to the power of 4. Then we have the x squared. So x squared minus 4x squared is negative 3x squared. And we're done with that. And now that we're done with those ones, I'm just scratching it out. Then we have this. So negative 20x, and there's nothing else with an x. So minus 20x, and then 100 plus 4, which would just give us 104. So positive 104. Okay, so this is what we have. And we have to find the minimum value of this. Okay. So to find this minimum distance, if you take the expression that is under the radical, under that square root, all we're going to have to do is find out at which x value or x coordinate that this will end up being at a minimum. Because if we find out which x coordinate would make this expression a minimum, when we substitute that into this, it's going to give us the minimum value of this entire expression. So I'm going to separate this. I'm only going to use this right now and try to find out what exactly the minimum value of this expression will be. Okay, so to find this minimum value, we're going to derive this expression. So I'm going to take this expression and derive it, and let's see what we get. So let's just say it's y is equal to this. So it's going to be y prime is equal to, and so we have 4x to the power of 3 minus 6x. We're basically deriving just like we have throughout the paper. Then minus 20. Okay, so this is what we get when we derive this. Now, to find the minimum value happens at the turning point. To find the turning point, you're really just going to make your gradient equal to 0, because the gradient of a turning point is always 0. That's why it's stationary. So 0 is equal to 4x cubed minus 6x minus 20. Okay, then we have to factorize this. Okay, so this was for 8 marks. That's probably why. So you see, we have to factorize a cubic function. Again, so this is a cubic function, but we do not have x squared, and that's not a problem. So first of all, to factorize the cubic function, you look at the constant term, and you're going to get factors of that constant term. So factors of negative 20, that will be 1 and negative 1, 2 and negative 2, 4 and negative 4, 5 and negative 5, 10 and negative 10, and 20 and negative 20. And then you're going to have to substitute these values into this and see the one that gives you 0. So 1 does not work. It gives us negative 22. Let's try the next one. Negative 1 gives us negative 18. And then 2 gives us 0. So 2 works. So we're going to use 2. And let's go ahead and we're going to say that now, since 2 worked, it means that, remember, the solution is x is equal to 2. The factor is x minus 2. It's like taking the 2 over. So it means x minus 2 is a factor. Let's just keep that in mind. Okay, then to factorize, we draw a letter L, but backwards. Then the number we put here is the one that worked, which was the 2. And then we're going to put the coefficient of everything we have here. But the thing is, it must be in the order of x cubed, x squared, x, and your constant. Okay, that's the cubic part. So the coefficient of x cubed, we can see that's 4. But then we don't have x squared, so we're going to give it a coefficient. Because it's not there, we're going to say it is 0. So we're going to put 0 as the coefficient of x squared. And then we have the coefficient of x, which is negative 6, and negative 20 as your constant. Okay, now that we have all of this, let's go ahead and start simplifying. So first of all, we drag 4 down, and we're going to say 4 multiplied by this 2 over here. So 4 times 2 is 8. Then 8 plus 0 is 8. Then 8 times 2 is 16. 16 minus 6 is going to be 10. 10 times 2 is 20. 20 minus 20 is 0. We ended with 0, so we know everything is correct. So it means these are our factors. See, when we had this, we're going to now say 0 is equal to, the first factor we had was x minus 2. That's why the 2 worked. So we have x minus 2. Then open a bracket. Now these are our other factors. Remember, they are in the order of x squared, x, and the constant. So we have 4x squared plus 8x plus 10. Okay, so this is our factors and we can just factorize now. So 0 is equal to x minus 2. Then factorize this. Well, so I can just say that x is either equal to 2 or 4x squared plus 8x plus 10 is equal to 0. Then I see that there's a common factor of 2 all through. So I can divide both sides of the equation by 2. And so we get 2x squared plus 4x plus 5 is equal to 0. Then we can factorize this. Then if you try to factorize this, like normally or using the quadratic formula, you will notice that it does not factorize. So it means that there is no solution for this. And again, we have one solution only. X is equal to 2. Okay, so since x is equal to 2, it's the only solution that we have. We don't even have to test and see whether it is the one that's going to give us a minimum value or not. Okay, so see, it has no solution. It has an I in it. That is an imaginary number. But of course, on your calculator, it would say math error. So this is what we have. We have x is equal to 2. So that just really means that x is our solution. So we know that x is equal to 2. And all we have to do is take that and substitute it into this. If you like, put it into this, but it's not necessary. You can put it straight into the distance formula. So we're taking this distance formula and we're going to put in place of x, we will substitute 2. You can put that on your calculator and see what you get. And we get that distance to be 2 square root 17. So the distance is 2 square root 17, which we can just round off to 2 decimal places, which is going to be 8.25 units. Okay, so that is the minimum distance. And that is it for question 9. And then we move on to question 10.